Well, hi guys. Now I'm going to do for you question 4 of the Maths Methods CAS Exam 2 from 2006. Now this is the first year that the CAS curriculum became mainstream, and this is a question about a train, a super train, and it's a super rotten question. So because, the reason being because it's fairly abstract and it's the last question on the paper, and this is when your brain has gone to mush and you're thinking, oh dear, what can they throw at me next? Well, this is a good example of what they can throw at you. So you keep your cool, and you chill out, and you look for easy marks, and you remember that these kinds of questions where there's A, B, C, D, E and lots of stuff, there's a story. It all integrates and one part leads to another. So you've sort of got to piece together an idea in your mind about where we're going here, rather than just panic and try and answer random questions, because that really doesn't get you very far. They lead somewhere, and there's like a little fabric being woven together as the parts of the questions unfold. So that is my little pep talk. You can do it, right? You can do it. So don't give up and freak out with all the pronumerals everywhere, because there's a blizzard of them in this question. Right. We've got a part of the track for Tim's model train follows the curve passing through A, B, C, D, E and F. Well, you know, goodness, that's good for starters, isn't it? A, B, C, D, E and F shown above, right? Check it out. All right. I think I can cope with that, can't you? Tim has designed it by putting axes on the drawing, as you do, as shown. This track is made up of two curves, one to the left of the y-axis and the other to the right. Now, alright, so it looks like we've got one function to the left, one function to the right. Okay, you still with me? Good. B is the point 0 and 7, that's the y-intercept, guys. Right, well that's the first bit of numerical information we've seen, and that's mighty good to see. The curve from B to F is part of the graph of that thing. It's a cubic. Alright, got it? Px cubed plus qx squared plus rx plus s, where p, q, r and s are constants, and f, now this is the gradient at the point where where x is 0 is 4.25. So we've got two bits of information here, guys. We've got at where x is 0, we've got the y-intercept and we've got the gradient, right? Well, that's got to give us two pronumerals. Two clues has got to give us two pronumerals. So let's go. Do you see how I'm thinking? That's what you've got to think. All right, A1, show that s is 7. All right, so come on. Now, how do you show s is 7? Look at the equation. Well, look, x is 0, right? X is 0. So you imagine what's going to happen when you plug 0 into that equation. Yes? What are you going to get left with? S! That's right. So let's do that. You see, now I've got that there. F of 0 equals p times 0 cubed plus q times 0 squared plus r times 0 plus s right now. But we know the value of f of 0, don't we, guys? Yes, it's 7. That equals 7. So that just simply tells you that S is 7 as required. Okay, put a box around it. Thank you, Mr. Box. Alright, so now you did that okay, didn't you? Yes, you did. Okay. Now, we're going to do the next bit now. What are we got to do now? Show that R is 4.25. Alright, you have a go. Pause the video and come back to me when you're ready. Alright, you're back? Okay. Now, we're trying to prove that R is 4.25. We'll look back at the clues. Okay, the gradient when x is 0 is 4.25. So that tells me we've got to do a gradient function, doesn't it? I think so. Come on, let's go. So therefore, f dashed x equals 3px squared plus 2qx plus r. Now, don't freak out. Just relax and do that. You'll be right. Now, this is the same process as we just did for A part 1, you see? If f dash 0, when we plug in 0 for x, all those x terms on the right except the r term are going to disappear. And we know that the f dashed x when x is 0 is 4.25. So plug and play, guys. Plug and play. What do we get? Therefore, we get R is 4.25. Well, that's really good. Now, there's 2 easy marks for you, right? 2 easy marks at the end of the paper. So that's what you want to look at it. It's good, easy pickings. Okay? Now, right, now we've knocked off 2 of the pronumerals. We now know that f of x equals px cubed plus 2x squared plus 4.25x plus 7. Now, we're allowed to use that in subsequent parts of the question. You see how there's a fabric weaving together here, right? All right, now the next part says that the furthest point reached by the track in the positive y direction occurs when x is 1. And we've got to assume that it's a positive cubic. That's what that p is greater than 0 means. And we have to use this information to find p in terms of q. I think we need a chill pill. All right, so this is 2 marks. This is 2 marks. I'm just going to start by writing out what I know so far. I've turned the 4.25 into 17 over 4, guys. Now, what I've got to do here is I've got to use this information. We're looking back at the model train graph, and we know that the hump to the right of the y-axis, that's the point where the track is the furthest away. Right, from the wait a minute, what do I say? The furthest point reached by the track in the positive y direction means the furthest it is away from the x-axis. Do you see that? So what I've done there is I've basically just taken my chill pill, written out what f of x now is in view of the 2 foregoing question parts, and then I've basically said, well, okay, the hump must be at a point where the gradient is 0, okay? So I've done the gradient function and I've set it to 0. And p and q were all that was left in terms of pronumerals, and basically I've put it as an equation equal to f dashed of 1 equals 0, and that enabled me to get, okay, what they said, q in terms of p. So now I've got that. Now, how did you go with that? Did you go okay? I hope you did, because it's not impossible when you basically just believe that you can do it, you know? You can believe you can do it. Now we're down to 1 pronumeral, guys. We're down to 1 pronumeral in this beastly question. Okay? Alright, so that's what it comes to, yeah, okay? And Mr. Box. Thank you, Mr. Box. Okay, now what do we got now? F of 1. Find f of 1 in terms of p. Oh, well, that's alright, because we now know what the equation is, and in terms of just the p is the only pronumeral left to find, guys. So we can just plug and play. Yeah, there it goes. So therefore, f of x is, okay, it's all in terms of p now. You'll notice that second term on the right-hand side, I've turned the q into its p version from the previous part, okay? So you're right with that now. Good. Okay, so I think I'm just going to, what have I done there? Let me see. Oh, you're plugging in 1. And that's what I've got. So that's all I need to do now. Probably I need to pretty that up a bit, because that's looking a bit messy. Is this only a 1 mark question, so don't muck around too much with it. Just fix it quickly. It's only 1 mark, guys. Okay? So what have I done there? I've just basically just... See, I'm probably going to need that in a prettied up form, because you can absolutely bet your bottom dollar that I'm going to have to use that information somewhere. That wasn't just a random question, guys. That's got a purpose to it. It surely has. Okay, so I've prettied it up. Now I'm good to go again. Okay, now let's see what else they throw at us. Yes, thank you, Mr. Box. Now what's this? Find the value of a in terms of p for which f dashed a equals 0, where a is greater than 1. Well, my goodness, 2 double chill pill. What? Well, come on, read it again. We can do this. It's only a 1 mark question. It's not supposed to be hard. You have a go now and pause me, and then come back when you're ready. Okay, you're back? All right, now, if you look back at the graph, guys, we've already determined that the first hump in terms of a local maximum on this graph occurs when they told us when x was 1. So that's the point C. on the graph, if you look back at the graph, okay? Now, this question appears to be asking the value of another value of x, which we're going to call a, specific value a, for which there's another local something, max or min, right? And a has to be more than 1. So I think this probably, on the graph, if you think about it, I think that equates to point E. Do you think so? Because they're saying a is greater than 1, all right? So, how do we do that? Well, I think we do the following. We basically get the gradient function, okay, there it is. We just determined that in the question above, didn't we? Or I wrote it out in the question above. That's the latest version that we've got of it. Okay, now what have we got to do, guys? Think about it. We've got to find the value of a for which f dashed a is 0. Okay, where a is greater than 1. Well, I think we plug and play, don't you? I think we plug and play. So we put an a in there. There it goes. There it is. Okay, now, okay, so what have we got to do? We've got to get a in terms of p. Well, I must say it's looking pretty disgusting, don't you think? Apparently f dashed a equals 0. Well, let's do that. Makes it a little bit simpler. Not much, though. Now, look, you've got to think, look, this is a 1-mark question. Look at the disgusting looking expression I've got there. So how do we sort out a in terms of p? Well, guys, we get the calculator and hopefully it'll solve nice and easily, okay? Yeah, we solve it for a and I did it. And look how beautiful it came out. I mean, yeah, see, look at that right-hand side of that little calculator screen dump there. Now, we've got a is 17 over 12p. Well, who would have known? Who would have known? Or a is 1. Now, come on, guys, we can't have two expressions there because, do you know why? Look at the question again. Look at the question above. Okay? It says there, find the value of a in terms of p for which f dashed a equals 0 and a where a is greater than 1. So I'm chucking that out. Goodbye, Mr. A equals 1. Don't want you. You're not going to cost me any marks. So now we're done, guys. We've got it. Look at that. A is 17 over 12p. For you and me, Mr. Box. Thank you, Mr. Box. Look, we did it, guys. We got another mark, okay? So that, to me, is the x-coordinate of the local minimum at E. See how I'm trying to build up a picture of what they might ask me next? It all interconnects, okay? All right, how are you going? Still with us? Good, okay. Here comes the next bit. Now, what are they doing to us now? If a, they're giving us a value of a. Well, this is promising. If a is 17 over 3, show that p is 0.25 and q is minus 2.5. Well, I'm happy because that means we're out of pronumeral land and back into the land of the living. Real numbers here. So I think, what do you think? Come on, pause me and come back. Okay, you're back? Good. Okay, I think we just plug and play. A is 17 over 3. Look at the question above. See? It all leads on, doesn't it? Now we solve it for p. That's easy, isn't it? Look at it. All we really need to do is say 12p equals 3. Or p is 3 over 12, which is 1 over 4, which is 0.25. Excellent, okay? Yes, that deserves a box. Thank you, Mr. Box. Now, what are we going to do about q? Where's q? Come in, q. Oh, there's q. Up the top right-hand side of the page. The top right-hand side of the top box on the right-hand side top. There's q in terms of p. Okay, we've got p, so we can do it. Okay? Yes, there it is. Thank you, q. Oh, my goodness. So we can just plug and play. And, oh, look at that. 12p, if p is a quarter, then 12 times a quarter is 3. 3 plus 17 is 20, so it's minus 20 over 8. And let's simplify that. That would be minus 5 over 2, which is exactly what they said, minus 2.5. Oh, wonderful, isn't it? We've done it, guys. Look at that. So now they've told us what A is now. That A is the coordinate of E, of local minimum E in my book. And Now we've got P and now we've got Q, and we're all rid of the pronumerals. We've got ourselves a real live cubic expression with no pronumerals for the coefficients of the x terms. Alright, so what have we got to do now? 2-mark question. For the following, now see we've got the proper cubic now without any pronumerals. Good. Now find the exact coordinates of D and F. Pause me, come back. Okay, you back? Alright, good. D and F, come on, what do you do for that? D and F. That should be easy enough. Come on. It's a 2-mark question, so you've got to state what you're going to do, and then you just come up with an answer. This is a calculated question, guys. Okay? So therefore, f of x equals 0, of course it does, and then you just solve it for that. And on the calculator there it goes. I did it for you, and I got, of course I didn't put any restriction on the domain of it, because I was in a hurry. X is -1, which won't work because that's to the left of the y-axis, okay, and f of x only applies to the right of the y-axis. So therefore x is 4 and x is 7. Done deal, guys. Done deal. Yes, yeah, we'll accept both of those. Now, remember you've got to give them the coordinates, okay, of D and F, so that's 4, 0 and 7, 0. That's what you have to say. Don't just say x is 4 or x is 7. You'll do your marks. Good, Mr. Box. Thank you. Good. Always read the question before you leave it. I'm feeling good now. Are you? Good. Okay. Let's gird your loins for the next bit now. whatever that is. I'll find the greatest distance that the track is from the x-axis when it is below the x-axis. Correct to 2 decimal places. Well, that's point E, isn't it? So there's 2 ways you could do that, but the way I did it... Oh, wait a minute. Pause the video quick and come back. Okay? Alright. You back? Alright. Now, what I did was I remembered what happened in part B3 where I got that thing. Look back at it. You'll see I solved it for A in terms of P, didn't I? For that thing where f dashed A equaled 0 and A was greater than 0. Yes? And I was saying at the time that was point E, the local minimum. Well, we found at that point that A is 17 over 12p, and now we know, guys, that P is a quarter. So we just plug and play for the value of A today. Hooray. And what do we get? Yes, we do. And then we go f of 17.3, and we get the y coordinate, which is kind of the distance, except we don't need the minus bit. Okay, we just need the distance, yes? So it looks like 3.70, what did they say, 2 decimal places? Yes, always look for the decimal places. 3.70. And I don't know whether it's just units, isn't it? Units, okay, Mr. Box, thanks. Alright, how'd you go with that? Yeah? Now, you could have also done that by just basically solving for the gradient equals 0, and you would get 2 solutions. You'd get C where x equals 1, and you'd get E where x equals 17 over 3. So that's the other way you could do it. But they did give you the easy way out by getting you to do B3 previously. That's what I mean by the fabric of coherence in the way these questions are structured and the way the sequence of them follows on in a way where there's a story unfolding here. Okay, they call it scaffolding. Okay. Yeah, alright, what do we got here? The curve from A to B. Okay, they're going to hit us with the curve from A to B now. That's the left-hand side of the y-axis, okay? G of x equals, it looks like it's a 1 over thing. A over 1 minus bx, where A and B are positive real constants. The track passes smoothly from one section of the track to the other at B. That is the gradient of the curve. The curves are the same. They're the same where it hits the y-axis there. Okay, that's a big clue. We need that. We're going to find the exact values of A and B. Alright guys, pause the video and come back. Alright, you back? Good. Now, we need 2 unknowns, A and B. Therefore, to get 2 unknowns, you need 2 clues which lead to 2 equations. That's what you need. Now, what might those equations be? Well, guys, they're always about values and gradients. That's what they're always about. So, come on. what is the value of y, in other words g of x, when x is naught? Well, yes, it's 7. And what is the value of g dashed x when x is naught? Yes, they already told us that it's 4.25, and they've just reminded us that the gradients of the two curves where they join at x is naught on the y-axis is the same. It's a smooth changeover, so the gradients are the same and the values are the same. So that's all we need to do here. We just need to come up with the two equations and then plug away and solve. So we know that g of naught equals 7, which gives us this equation. That's what g of x equals a over 1 minus bx becomes when x is naught. Yeah? And g is 7. So g of x is 7. So therefore we know a is 7. Well, that was nice and easy, wasn't it? Come on now, we've got to do the gradient thing now. Oh, well, actually, I probably didn't need to do this because they told us. I just forgot in an earlier part of the question that the gradient was 4.25 in the very, very first intro statement. But, you know, pardon me, my brain was a bit mushy when I did this as well. So I've actually solved it again for you. But look, it wasted a little bit of time, but not too much. So f dash 0 equals 4.25, doesn't it? They told us that, and I just worked it out for no good reason because I forgot. Now that means that g dash naught must be 4.25. So we better get an expression for g dashed x. Okay, we're very near the end now, guys. Don't lose it now. Now, this is a little bit complicated, so I wrote it out. Yeah, now just see if you can follow what I've done there. Oh dear me. What have I got? Just go up to here. Now I've got gx equals 7 over 1 minus bx, which is 7 times 1 minus bx to the minus 1, right? So therefore g dash of x must be 7 times minus 1 times the thing to the minus 2 times the derivative of the thing, which is minus b, isn't it? Yeah, okay, good. So that gets us, now I'm going to rewrite that out in a more convenient way again. Now I've fixed it up. It becomes that. Alright, now, okay, so therefore what I'm saying is that the actual gradient is 17 over 4, which is 4.25, is equal to 7b over 1 minus nothing squared, right? So therefore that just is 7b. So therefore we can work out what b is. Oh, we're so close. Therefore b is 17 over 28. Wacko! There you go, guys. We've done it. Therefore, A is 7 and B is 17 over 28. Mr. Box, are you there? Thank you, Mr. Box. There you go. This is excellent, guys. We did this nasty question. All right, now there is one more bit to go, so let's not get too excited yet, but we're nearly there. Heavens, that's worth 4 marks. Goodness, what are they going to hit us with now? Find the area of the shaded section bounded by the track between x is minus 2 and D. That's an area question. Well, that doesn't seem too bad. There's our thing. There's our diagram. What is it again? Between x is minus 2. Oh, so it's that left-hand extremity and all the shaded bit up to and including D. Well, that doesn't seem very hard to me, guys. We've got both of the functions sorted out. We've just got to do the integral. Definite integrals of the g function from minus 2 to 0 and from the f function from 0 to d, which was 4, wasn't it? I think that's pretty easy. Goodness, I don't know where the 4 marks are coming from. Alright, it's a bit of an anticlimax, isn't it? Let's just do it anyway. We get this. That's the g function, because we've got the coefficients worked out from the previous part. And there's the f function in all its glory. And if we just put that into our calculator, presumably, we'll get it. And I did, and there it is. Yes, okay, I defined the g function in my calculator as f2 of x, and then I just did the area thingies, because f1 of x is already defined in my calculator. There it is, 33.83. Have a look at the question again, 2 decimal places, so it looks like 33.83 for you and me. There it is. Box time. Square units, Mr. Box, thank you. That's it, guys. We did it, okay? And you're a star. Thank you for listening, and I hope you got something out of that. That was a typical abstract, pro-numeral-infested VCAR question, and you can do it, okay? So have confidence, and let's go onward and upward as we go. Thanks for listening. We'll see you next time.